Hello, my name is Balint Tillman from University of California, Irvine, and I'm going to talk to you about construction of directed 2K graph. This is a joint work with Athina, Markopoulou, Carter, Bratz, and Minas Gjoka. Our motivation is that we study graphs in many contexts and we'd like to generate synthetic graphs that look like real-world graphs. This is useful to run simulations and to test new algorithms on different realizations of these graphs. In this particular case, we focus on directed graphs and how to generate synthetic graphs with exactly matching certain properties of these networks. We adopt the DK series framework that was introduced in SICOM 2006 by Mahadevan et al. It specifies a series of distributions in increasing complexity, namely it is the counts of degree labeled D-side simple connected subgraphs. 0k by convention corresponds to Arashreni graphs with fixed number of edges, 1k specifies degree sequences, 2k specifies degree correlations or joint degree matrices, 3k specifies the number of degree labeled connected subgraphs of free nodes, which also gives clustering coefficients, nk specifies graphs with n nodes with an isomorphism. Nice properties of DK series are inclusion, convergence, and the trade-off between matching graph properties with higher accuracy and the increasing complexity of defining input distributions or algorithms for construction. Our earlier contributions to this field are highlighted in red, and for more detailed introduction to this topic, I invite you to read the paper. Since DK series was defined for undirected graphs, we have extended it to directed graphs. In particular, we have defined directed 2K as a combination of directed degree sequences and degree correlations as shown in the example. There are three classic problems to solve. First, realizability. We have achieved this by showing the necessary and sufficient conditions for graphs with these exact properties to exist. For our second problem, we have designed an efficient algorithm that generates at least one such realization. Third problem is sampling from the space of all graph realizations with the target D2K. We have not solved this last problem explicitly, but we have shown some intermediate results. The key idea used in this paper is the mapping of directed simple graphs to bipartite graphs with non-coords as shown in the animation. This is a classic idea that dates back to the 60s, but it allowed us to leverage all the machinery from undirected 2K construction. Eventually, we worked with a joint degree attribute matrix to capture degree correlations in the bipartite representation, and we naturally used the directed degree sequence to define non-coords. The challenge remained to show that the combination of JDM with the non-coords are still possible to solve. Targeting D2K helps in constructing more realistic graphs like this example Twitter graph from Snap. D2K exactly matches degree correlations, while other baselines like directed Erdős-Rényi graphs or directed degree sequence realizations are not good at capturing this property. For more details on the algorithm and experimental results, I refer you to the paper, and please visit our website at odysseys.calite2.uci.edu. Thank you.